Hey, and welcome to the first online lecture I'm doing. I'm sure there'll be more of these. Well, let me come into frame. Hey. So basically, here's how I'm thinking class is going to work. There will be these videos available. You signed up for a face-to-face class where somebody would present the material. That's what I'm doing here. The homework, you will still do the homework as before. Everything about that is the same, other than I have updated the dates to reflect us being out, and we took a little material out. So you watch the video. Now, I will be available by Zoom, and if you haven't found out about Zoom, I'm actually going to try to make a video about Zoom, how to sign up for it, sometime later today, if you don't know, and then we'll talk about that. But I will be available by Zoom at our normal class time. So if you're trying to do this, you have questions, you can contact me by that, or we can set something else up possibly. All this is really fluid right now, and we're not really sure exactly how this is going to work. But today, I want to talk about a topic here, and it's a real simple topic. And there are two ways you'll be asked this. The first way is restrictions on a variable in a domain. And the second way you'll be asked is the domain, in a denominator, not domain. And the second way it'll be asked is, what is the domain of a rational function? Both of these boil down to the very same thing, and that is, cannot have a zero, let's write the word, in the denominator. All right. And we know this. We can't have a zero on the bottom of a fraction. We can't divide by zero. And so when we're talking about restrictions on a variable or domain of a rational function, that's what we're talking about. What number could we plug in for our variable that would cause us to have a zero? For instance, let's say I have this expression. If I have 7x over x minus 2. All right, so here's the question I'm asking. What number could I plug in right there for x that would cause a zero on the bottom? Well, this one's pretty simple. I mean, it'd be 2, right? Because let's suppose, all right, suppose that x equals 2, then what we're going to have is 7 times 2 over 2 minus 2. That would be 14 over 0. See, if x is 2, it causes a 0 in the bottom denominator. So we would say, actually, x cannot equal to 2. Or 2 is the restriction. Usually you'll be asked, what number, what are the restricted numbers? And then, of course, that would be 2. But another way of saying is that x can never be 2. And again, no matter which way you're asked this question, whether you're asked for the restriction on a variable in the denominator or if we're asked for the domain of a rational function, this is what we're wanting to do. What causes a 0 in the denominator? All right. So let's say it's not quite as easy as that one. Let's say we're given an expression like 3x plus 1 over 7x minus 3. If we want to figure out the restriction, there's pretty much a pattern we can always follow. We can always take whatever's on the bottom. Okay, bring it out here. 7x minus 3. Now, I don't want that to equal 0, so I'm going to use not equal to. You could use equal to. It's not really important. But then I'm going to solve this little equation the same way we've been solving equations all along. Add 3 to both sides. I'm going to divide by 7. And so, what does this tell me? This tells me that x cannot be 3 over 7. Why is that? Because if x is 3 over 7, will equal to 0. So there is our restriction. And pretty much the ones you're going to have to do are just going to have one restriction, which is great. So what you need to do in these problems, take the bottom, set it equal to 0, solve that, and that will be your restriction. Okay? Thanks.